Heartily welcome to the learners. Myself Mr.T.SATHIsh Kumar, working as a assistant professor in Electrical and Electronics Engineering Department in SA Engineering College, Autonomous Institutions. Welcome to the GATE coaching. My topic is going to be nodal analysis. The another name of the nodal analysis is going to be node. The another name of the nodal analysis is going to be a node voltage method. Why it is called as a node voltage method? In nodal analysis, we are going to find the value of the voltage. We are going to find the value of the voltage at any node in electrical circuits. So only we are going to be called as a node voltage method. And what is the meaning of the node? Node represents in your electrical circuits where the junctions point where two or more elements connected together, that we are going to be represented as a node. Node 1 as well as your node B as well as a node A. It represents the elements resistance R1, R2 as well as R3 were connected at your common point. This point is going to be called as a node. Same thing, the resistance R3, R4 as well as your R5 which is connected to the common point called as B. This point also we are going to be represented as a node. And next, there are the two types of nodes in nodal analysis. One is going to be a non-reference, one is going to be a non-reference node, another one is going to be a reference node. In the electrical circuit shown here, there are the two nodes represented. One is going to be a node A and node B is going to be a non-reference node. And next one is going to be a reference node which is going to be the common for your D as well as C. The reason is there is no element is connected between the nodes D and C. So it is going to be the common for the node B and C. So it's going to be represented as a reference node. And what is the meaning of your supernode? Supernode is going to be a dependent independent voltage source which is connected between your two non-reference node. This is going to be a this is V1 as well as your V2 is going to be your non-reference node where V1, V2 we are connecting your voltage source. So we are going to be represent that as a non-reference node where your voltage source is going to be connected. That we are going to be represented as a super node. And next, nodal analysis. Now we can discuss the topic on your nodal analysis. What is the purpose of the nodal analysis? Is used to determine the voltage distributions between the two nodes in the electrical circuits. Main thing is going to be your voltage distributions. Voltage distributions between the two nodes that we are going to be calculated by using your nodal methods. Here the simple circuit is going to be given. One is going to be a node A as well as your node B. Here we are going to find the value of your voltage VA as well as your VB by using your nodal analysis method. These are simple circuits which have only two nodes. In electrical circuits there are n number of nodes we have. For n number of nodes we can find the value of your voltage distributions. Next, what are the steps involved in your nodal analysis? First thing is going to be your identifying your nodes. First thing is going to be your identifying your nodes. How we can identify? Already I have shown your some circuits. We are identify two nodes, a node A and B. Like that, for a given circuits, we have to identify how many nodes are there. Second step, we have to select your reference node. Already we have discussed that there are two types of nodes in your nodal analysis. One is going to be your non-reference node, another one is going to be the reference node. That reference node is going to be your common for your non-reference node. That we have to be select. We have to choose. And next, we have to label your nodal voltage. If there is a number of nodes are there, we have to specify how many node voltage are there. For example, V1, V2, V3 to Vn. That is your third step. After finding your node voltage label, we have to apply your Kirchhoff current law method. Already we have know that Kirchhoff current law method is going to be the current entering into the junction is equal to current leaving into the junctions. That method we are going to apply in the electrical circuits to find the value of your node voltage. After that, we are going to use your Ohm's law relations in the same equations to find your voltage distributions among your nodes. Finally, we have to solve the equations to find simultaneously to find all the nodes voltages till your n numbers. These are the steps involved in your nodal analysis. Repeating once again, step 1 is going to be your identifying the nodes, second one is going to be the selecting your reference node, and third one is going to be the label node voltages, and third one is going to be apply a Kirchhoff current law, and next is going to be your Ohm's law relations, and finally we have to solve your equations to find your node voltages for n numbers. Now we can see a simple problem on your nodal analysis. This problem represents to determine the voltage at each nodes. Okay, we are going to find the voltage at each nodes for a given electrical circuit using nodal analysis. This is a simple circuits. We have one voltage source. We are connected resistance connected in series as well as parallel combinations. We have to identify where are the nodes, what are the types of nodes here, non-reference node as well as your reference node, and you have to label everything. We are going to do it, and we are going to find your voltages at each nodes. First step is going to be your identifying nodes. Identify all the nodes in the electrical circuits. Already I have told, okay, the meeting point, the junctions. The meeting point represents your common junction point where electrical elements are connected. Your elements, a 5 ohm resistor as well as a 30 ohm resistor as well as your 10 ohm resistors is connected to the junction. This point is going to be the node 1. Second one, again your 10 ohm resistor as well as your another 10 ohm resistor, again your 20 ohm resistor is connected to your another node called as N2. And next node, it is connected, the 30 ohm resistor as well as the 10 ohm resistor is connected to the common ground. Okay, this is going to be a common node which is going to be called as a N3. So we are identifying 3 nodes. One is going to be the N1 as well as your N2 as well as your N3 for a given problem. This is the first identifying the nodes for a given electrical circuits. And next, select a reference node. Already we have discussed that there are the 2 types of nodes are there. One is your non-reference node. One is going to be your non-reference node, and next one is going to be your reference node. Here we have to select which one is going to be a reference node and which one is going to be the non-reference node. The node N1 as well as your node N2 we are going to be called as a non-reference node, and your node N3 is going to be your reference node. Here the node N3 is going to be the common for the node N1 as well as N2 of non-reference node. This is the selecting a reference node. Before calculating your distributed voltages in your node. And next we have to enable the voltage. Okay, what are the voltages we have to find in your nodal analysis? Already I have specified two nodes. One is going to be your non-reference node, another one is going to be a reference node. Here we are going to find the voltages for your non-reference node. One is going to be your V1, another one is going to be the V2. These are the unknown voltage. Unknown voltage V1 as well as your V2 we are going to find. This is the questions given. Determine the node voltages. Here we have to determine the voltages at node V1 as well as your V2 for a simple given electrical circuits. And next, and fourth step is going to be apply your Kirchhoff law as well as you are using Ohm's law. Then we are going to solve your equations to find all your node voltages. This is your given circuits. For this we are going to apply your Kirchhoff law equations and we are going to determine your node voltages. We can write a unknown voltage V1 V1 minus 100 divided by, I am applying your Ohm's law equations as well as in your Kirchhoff current law equations to form your equations, and we are going to solve your nodal voltages. 100 divided by V1 minus 100 divided by 5 plus V1 divided by 30 plus V1 minus V2 divided by 10 is equal to 0. This is my first equations for node V1 and second equations. Okay, and we will be going to form your second equations for your node 2, that is your V2 minus V1 divided by 10 plus V2 divided by 10 plus V2 divided by 20 is equal to 0. Second equations for node V2. Now I have applied your Kirchhoff current law as well as the Ohm's law for your equations. Now I am going to simplify this equation 1 as well as your equations 2. After that I am going to solve simultaneously to find your node voltage. Already we have formed equations V1 minus 100 divided by 5 plus V1 minus V2 divided by 30 plus V1 minus V2 divided by 10 is equal to 0. Equation number, if you simplify these equations, we will get 0.333 V1 minus 0.1 V2 is equal to 50 for your node 1 equations. Node A, same thing. When we go for your second node, V2 minus V1 divided by 100 plus V2 divided by 10 plus V2 divided by 20 is equal to 0. Second equations, if we simplify this second equations, we will get minus 0.1 V1 plus 0.25 V2 is equal to 0. Now this is for your node B or node V2. Now equation 1 as well as your equations 2 should be solved to find your distributed voltages. Okay, we got two equations. One is going to be your 0.33 V1 minus 0.1 V2 is equal to 50, equation number 1. And next one, minus 0.1 V2, is going to be a V1 plus 0.25 V2 is equal to 0, second equations. By solving these two equations, we can identify your V1 as well as your V2. After solving these two equations, we will get V1 is equal to 68.2 volt and your V2 is equal to 27.5 volt. This is the final solutions where the distributed voltages for your given electrical circuits, V1 as well as your V2. Yes, this voltage your V1 voltages is equal to 68.2 volt and next one your V2 voltages is equal to 27.5 volt. These are the calculated voltages using your nodal analysis. This is the simple method we have solved one problems. And next we can go with your next method. Second problem, here also we are going to use your same nodal analysis but in different way. Here it is given all the elements in the circuits are ideal. We have to find power delivered. In second problems, again we are going to use your same nodal analysis method, but here in the circuits we are going to find power delivered by the 10 volt voltage source. This 10 volt voltage source, how much power is delivered, that we are going to calculate. Main thing is here also calculation power, but we are going to use your nodal analysis. Reason is here if we have one node and here the resistance value is not given, so we are not able to use some other method. In nodal analysis we can simply find your power delivered by the 10 volt voltage source, and the options are given. This is your get questions, already previously it is asked. It is given whether the power delivered by your 10 voltage source is 0 or 50 or 100 or depend upon the value of your alpha. Based on your alpha, whether the power value will be decided. In this, which option is going to be the correct, we are going to calculate. The next steps. Okay, this is your problems. Again we are going to form your equations for a given network. Before forming your equations, we have to identify your nodes. This is your node 1. Yeah, this is your node 1 V1, and next this is your node. It is your common node, or we can say it is a reference node. Now we are going to write your equations for this. One is going to be your node voltage V1 minus 10 divided by alpha. Here it is given the resistance value is alpha, so we are written the alpha values, plus V1 divided by 1, and next element is given V1 by the resistance, which is equal to, I am not taking a 2 ohm resistance because it is directly connected to your 10 amps. The 10 amps current only enters into the 2 ohms and it is enters into the node V1. So which is equal to 10 amps. Okay, already we know that your current I is equal to V by R. That's only use your Ohm's law relations. This equations also represents your Ohm's law, V by R values. If you simplify these equations, we can find the value of your node voltage V1 as well as your alpha value. So V1 divided by alpha minus 10 divided by alpha plus V1 by 1 is equal to 10. If you simplify this, we will get V1 minus 10 plus alpha V1 is equal to 10. Okay, and next V1 minus 10, commonly we can take alpha V1. Here it goes to alpha, is divided by your alpha is going to be a common. It's V1 to alpha, which is equal to 10 plus 10 alpha. Okay, if you simplify this, again we can take V1 out, 1 plus alpha, which is equal to, if you take 10 common, 1 plus alpha, this 1 plus alpha get cancelled, so we can take your V1 is equal to 10. So this is your node voltage. So your V1 is equal to 10 volt. Now we have calculated the node voltage V, and next we have to find the value of your current values. How we can find the current? Formula I is equal to V by R. So your voltage V is equal to 10 minus your V1. This 10 minus your this node voltage V1. So divided by, okay, your alpha values. Okay, we know that V1 we have calculated is 10 divided by alpha. So 10 minus 10 is going to be a 0. So your current I is going to be a 0. So we have calculated your V1 is equal to 10 and your current I is equal to 0 amps. Okay, the current supplied by your 10 volt voltage source is going to be your 0 amps. And next we are going to find the value of your power. P is equal to V into I, where V is equal to 10 volt and the current I is equal to 0. So it's going to be 0. The power delivered by 10 volt voltage source is going to be the 0 watts. Reason is, here it is given 10 volt and another side it is given as 10 amps. So the power delivered by the 10 volt voltage source is going to be the 0. This is the answer for your given problem. This is your questions for all the elements in the circuits. What is the power delivered? They are asked. Power delivered is going to be a 0. What is going to be the right answer? Thank you for everyone. We can continue in your next session. Thank you so much.